All right, welcome, and we are getting started on the second part of our semester exam. Starting us off here, we got this problem. Oh, I lied. We already did those ones. We're starting off here at 19. There we go. So they asked us to find the central angle that would generate an arc length of 78 meters on a circle with a radius of 6 meters. Well, we know that we're talking about arc length here, so we know we're using the formula length equals theta times r, or central angle times r. And they told us in this case that the length is 78 and that the radius is 6, and they asked us to find theta. So I'm going to plug in what I got here. So 78 equals theta times 6. I don't mean to put r. We know it's 6. And so if I work backwards here, I'm going to divide both sides by 6. That's cancel. And I end up with 78 divided by 6 is a 13 equals theta. So what this really means is theta is equal to 13 radians, which we usually put our radians in terms of pi, so it probably looks a little bit weird. In fact, I'm going to go ahead and convert this into degrees. I think that that's probably what they want us to do here, so let's just be mindful of that. So I'm going to take 13. If I want to convert to degrees, I multiply by 180 degrees and then divide by pi. Now, this one doesn't have a way to cancel pi, right? This pi on the bottom, there's nothing to cancel it with, so we're actually going to have to use it and divide it for this problem. So I do 13 times 180 gives me 2,340 degrees over pi. And we'll divide it by pi, and it looks like I'm going to end up with an answer where theta is also 744.85 degrees. So both those answers seem like good answers. It didn't say what to leave the answers in, so we'll just put both of them so we have them. For number 20, it says, find the following rounded to the nearest thousandths. We know thousand has 3 zeros after it, so we're going 3 decimal places. Now, these are a little bit tricky. Secant is weird. Remember, secant is the reciprocal of cosine. So really what they're asking is for us to put 1 over the cosine of 59 in our calculator. But this is in degrees, so it is very important that you put your calculator into degrees when you find this answer, or you're going to end up with the wrong thing. So I'm going to type in my calculator 1 divided by the cosine of 59 while my calculator's in degrees, and I end up with the answer 1.94 thousandths. So 9416, so 942. So we're going to go 1.942. Now the next one puts us back in radians, so it's important that we make sure we switch our calculator back to radians. And this time they asked us to find the tangent of 22 pi over 9. That's easy. We don't got to do anything extra for that. 22 pi divided by 9. When I type that in with my calculator in radians, I get 5.6712. So 671 is a good round answer. All right, 21. 21 asks us to find a few things for this problem. They asked us to find the amplitude, the period, the phase shift, and the vertical shift. So starting this off, the first thing that I noticed before I even start this problem is the fact that these parentheses are not doing us any good. We've got to make sure it's fully factored. So I'm going to factor that 6 out of there, so it's just x in there. So -5 times the cosine. Whatever's in front of x has to come out, so I'm going to put 6. 6x divided by 6 is x. And positive 30 pi divided by 6 is positive 5 pi plus 7. That's a little bit better. So it says first determine the amplitude. Amplitude is equal to the absolute value of A. In other words, I know that some of us have been putting the negatives. Please do not. A in this case is -5. The amplitude then is just 5. Don't put the negative there. So just 5 for our answer. Period is determined by taking 2 pi and dividing it by the variable b. Well, in this case, we know that b is that 6. So I'm going to get 2 pi over 6, which I can see I simplify. If I divide both of them by 2, that's going to simplify for me. 2 pi divided by 2 is pi. 6 divided by 2 is 3. So it looks like we have a period of pi over 3. The phase shift represents that left and right movement. In this case, we can see that left and right movement is going to be right here after we factor. Don't put left 30 pi or you'll get it wrong. We want to look here. Positive means we go to the left and then 5 pi units. So I'm going to put left 5 pi units. And then vertical shift is our up and down. In this case, I've got this plus 7 at the end in either problem. So we're going up 7 units for our vertical shift. All right, going on to this second page here, number 22. We're now in the no calculator section, so you should be putting your calculator away and trying to do these without the calculator so that you're practicing for what you need to know for this test. So it asks us to determine what happens when f of x and g of x are equal to each other. So let's just do that. Let's take this f of x and this g of x and set them equal. X squared minus 3 equals 2x plus 5. Well, the first thing that jumps out to me is the fact that one of them has an x squared and one of them has an x. And they don't have any other like terms except the negative 3 and the 5. So I think I need to move everything over to the left side. So I'm going to subtract 2x here. I get x squared minus 2x minus 3. These cancel. Equals a 5. And I'll also go ahead and move this 5 over and subtract it. So overall, I end up with x squared minus 2x minus 8 equals 0. Now this is a solvable problem because now we can attempt to factor it. I need two numbers that multiply to make negative 8, but add up to negative 2. So x and x equals 0. So adding up to negative 2 and multiplying to negative 8, I think that's going to be negative 4 and positive 2. Well, now I have two little problems to solve. X minus 4 can equal 0, and x plus 2 can equal 0. So we'll solve each of those. X equals 4 is one solution, and x equals negative 2 is the other solution. So there's two solutions we can get here. In 23, it says, what is the domain of this function? They give us two pieces here to work with. And when they're asking us to find the domain. So firstly, the first thing I identify here is square roots. Square roots, we know that we can take whatever's inside of them and make it greater than or equal to 0, and that represents the domain. So in this case, I've got 2x plus 9 is greater than or equal to 0, so it stays positive under the square root. So we'll subtract 9 from both sides. 2x is greater than or equal to negative 9, and divide by 2. X is greater than or equal to negative 9 halves. Another thing that we notice is if there is a fraction, we got a number on the denominator, that cannot equal 0. The denominator number cannot equal 0. Make that n and d for numerator and denominator. Denominator cannot equal 0, so in this case, x squared cannot equal 0. And that's a pretty easy problem to solve. We square root both sides. Well, the square root of 0 is still 0, so x cannot equal 0. So these are my two restrictions that I need to write a domain with. So I'm going to do a little number line here. I'm going to put my 0 on there. I'm going to put my negative 9 halves on here. Well, since negative 9 halves is x is greater than negative 9 halves, I know it's going this way. And I'm putting a bracket because it can be equal to negative 9 halves. And when I get to that 0, I know that I'm not allowed to equal 0. So I'm going to put a parenthesis and a parenthesis, blocking 0 off and restarting it. So it looks like my domain is, put a D in front there. Domain is negative 9 halves to 0. Union 0 to infinity. I did something wrong there, didn't I? This, we already said, was a bracket because we're allowed to equal negative 9 halves because it's got the equal sign right here. So bracket negative 9 halves to 0, union 0 to infinity. For 24, they gave us a few different little problems here. They said we got f of x and g of x, and they want us to find the following. They started off with find f plus g of x. So we're going to add them together. 3x minus 7 plus negative 8x minus 9. This one's easy. We just combine our like terms. 3x and negative 8x is negative 5x. Negative 7, negative 9 is negative 16. So we end up with negative 5x minus 16. For the next one, we got f minus g of x. So we're going to put f first again, so 3x minus 7. But we're putting a minus sign in between them this time, which means that negative is going to distribute into each of these. So this becomes positive 8x and positive 9. Then we can combine our like terms. 3x and 8x is 11x. Negative 7 and 9 is positive 2. So 11x plus 2. Same thing here, but they did g minus f. They did it backwards. So it's going to be negative 8x minus 9 minus 3x minus 7. Again, take that negative and distribute it in. So we get negative 3x and positive 7. Negative 8x plus negative 3x is negative 11x. Negative 9 plus 7 is negative 2 and ends up being the exact opposite of the last answer, and it's supposed to do that. And last, we got f multiplied by g of x. So we're going to multiply these two things together. So I'm going to multiply 3x minus 7 by negative 8x minus 9. And we're going to use that FOIL method. So first and outside, we multiply these two together. So 3 times negative 8 is negative 24x squared. And 3x times negative 9 is negative 27x. And then we'll do this inside, outside, these next two. So negative 7 times negative 8x is positive 56x. And negative 7 times 9 is positive 63. I do see some like terms there. Let's get those together. So I've got negative 24x squared. And we'll put negative 27x and positive 56x together. And that should give us 29. Yeah, 29x. And then we got this plus 63 at the end, and that's what that's going to look like. 25 asks us to do f of g of x. So we've got f of x and g of x, and they want us to compose those together, meaning we're plugging g into f. So I like to start out by writing f out. 3x plus 5, and I'm going to put parentheses around the x. What I'm doing is taking that x out and plugging in g of x. Then I want to plug g of x in. So I end up with 3, and then when I plug g of x in, x squared plus 2x plus 1, and then this plus 5. So we're going to distribute this in here. 3 times x squared is 3x squared. 3 times 2x is 6x. 3 times 1 is 3, and then this plus 5 at the end. So I only got 2 more like terms. 3x squared plus 6x plus 8 for my answer. On 26 says, given that you have 2 over x plus 3 and 1 over x, find the domain of the function by composing f of g of x. So again, we're plugging g into f, so into that x right there. So 2 over, I'm going to plug in that immediately, 1 over x plus 3. First thing that jumps out to me is this denominator is not going to work. I'm going to have to put it 3 over 1, and I'm going to have to add those two fractions together, which means I need to multiply the denominators by and numerator by x. So I get 2 over 1 over x plus 3x over x. And I get 2 over 1 plus 3x over x. And we're going to have a situation where we keep the numerator, change the sign to multiplication, we flip that denominator x over 1 plus 3x. And I get 2x over 1 plus 3x. And overall, what we care about with domain is this denominator cannot equal 0. So this cannot equal 0. So 1 plus 3x cannot equal 0. I'll subtract 1 to the other side. We get negative 3x cannot equal negative 1. Divide by 3. X cannot equal negative 1. 1/3. But we also know that this and whatever we plugged in are what's important. So go back to this top part, this g of x, and we look at g of x and say, what can x not be there? Well, here, x cannot equal 0. So our domain is that x cannot equal 0 or 1/3. So I'm going to write that like this. X such that x cannot equal negative 1/3, comma 0. That is the domain we're looking for. See if I can move some of this stuff over. It's going to get in my way in just a minute. All right, coming over to this side. 27 says, find the inverse of this function. Remember, inverses is where we take the x and the y and we switch them. So really, this stands for y. We're going to swap those two things. So I'm going to make this x equals, and instead of doing the square root of 2/5 x, I'm going to do the square root of 2/5 y. And we got to get x by itself, y by itself again. So I'm going to square both sides. That cancels this and this. X squared equals 2/5 y. And then we got that fraction. We could divide by the fraction if you want to. I think the easiest thing, though, is multiply by the reciprocal 5/2. 5/2. And I end up with 5/2 x squared. This cancels with this, equals y. In other words, our f inverse of x equals 5/2 x squared. For 28, it's the same idea, but they ask us to then figure out what f inverse of 8 is afterwards. So we need to plug all our stuff in and then do that at the end. So same thing, change this to a y and flip-flop the x and the y. So it becomes x equals the square root of 7y plus 29. So the first thing I'm going to do is I'm going to square both sides here. So squared and squared. That cancels out this square root here. So I get x squared equals 7y plus 29. And then we're going to need to subtract 29 here, subtract 29 here. Now that 29 doesn't have anything to subtract to, so we're just going to kind of bring it over here and leave it like so. So x squared minus 29 equals 7y. And our last step here, divide both sides by 7. And we get, I've got this like dead spot on my iPad. X squared minus 29 over 7 equals our inverse of x. So that is going to be your inverse function. And then we're going to go ahead and just plug in 8 to this problem. So we got to make sure we plug this 8 in right here to get our final answer. So when I plug in 8, I get 8 squared minus 29 over 7. And you could just put that in your calculator. We get 64 minus 29 divided by 7. And we get 5. So that is the actual answer you want to get to at the end. Make sure you don't forget that last step of plugging back in. For 29, it asks us to do f of x equals 16x squared plus 81. We want to factor that. I recognize that this right here is a sum of two perfect squares because I can take the square root of 16x squared. I can take the square root of 81. And when I do that, I get 4x and I get 9. If it was a difference of two squares, that is subtraction, we would do 4x plus 9 and 4x minus 9. But if it's a plus sign, this is where we got to include the imaginary solution. So we get 4x plus 9i and 4x minus 9i. Just remember, it's the same thing as a difference of two squares, but if it's a plus sign here, you've got to put imaginary i's at that last number. So I there, because the I squared will cancel the negative out. So for that, well, there's our answer. Oh, wait, nope, it said find the zeros. Those are linear factors. Don't put that. The zeros is that I set each of these equal to 0. So in this case, subtract 9i and divide by 4. I get x equals negative 9i over 4. And over here, I'd add 9i and then divide by 4. So x equals positive 9i over 4. Those are our two solutions. For number 30, for the polynomial function below, we got this crazy function. It says find each zero. The first thing before I even get down here and do all this stuff, the first thing I recognize is that this is factored, this is factored, this is factored, this is not. They definitely tried to trick you by not factoring that piece right there. So we want to make sure that we go in and actually do that factoring step. So right here, x squared minus 9, exact opposite of what we just did up there. This one is a difference of two squares, so it's going to be x plus 3, x minus 3. So we want to make sure we do that factoring step first. And it says find all the zeros. So I've got x equals negative 2 when I set this equal to 0, positive 1 when I set this equal to 0, negative 3 when I set that equal to 0, and positive 3 when I set that equal to 0. And the one that everyone forgets, what would make this little x out front equal 0? Well, we got to remember that that represents the 0, 0. So make sure you don't forget that one and leave it out. Next part says find the y-intercept, meaning if I plug 0 into this equation, what do I get? So I've got 0 times 0 plus 2 squared times 0 minus 1 squared. I'm going to use the original equation here, times 0 squared minus 9. And we want to see what we get. Well, look, it doesn't matter. You're multiplying by 0 right here in the beginning. That very beginning 0, if you multiply by 0 right here, it doesn't matter what you get for any of this. You can solve all this out. 2 squared is 4. Negative 1 squared is 1. 0 squared minus 9 is negative 9. Multiply this all together, but then multiply by 0. You're going to get 0. It's going to go to 0 because that 1 in front. So we overall know the y-intercept is 0, 0 here. Find the multiplicity of each 0. So we want to write each 0's multiplicity. So negative 2 has a multiplicity of, well, look right here at the exponents. Remember, the multiplicity comes from the exponent. So its multiplicity is 2. For the 1, we're going to look right here. The multiplicity is 3. For the negative 3 and the 3, well, each of them don't have anything attached on them, so they're both 1 because there's an imaginary 1 up in that that exponent there. So I'm getting messy here. So 3 has a multiplicity of 1, and negative 3 has a multiplicity of 1. And last, I've got that 0, which if you look in front, again, there's an imaginary 1 right here for my exponent. So 0 has a multiplicity of 1 as well. And then it says, explain what happens on the x-axis. This is really, really simple. For degrees 1, 3, 5, 7, anything that's an odd degree, it's going to cross the x-axis. And again, it's because it is odd. This same answer goes here for number 3. For part 2, it's going to bounce, or we can call it the fancy math word, be tangent to the x-axis. And again, the reason being because it's even. So anything that's even is tangent. Anything that's odd crosses or intersects the x-axis. And 31 asks us to list all the possible rational roots of this function. That's that P over Q formula. Really easy to use. We put plus or minus and then a parentheses. And for the top number, we list all the factors of 12 right here. All the factors that would make up the constant. Yeah, now we don't really care about that negative because we're putting plus or minus there. So I'm going to work outside to inside. So 1 and 12 would multiply to make 12. 2 and 6 would multiply to make 12. 3 and 4, and I think that's going to be it. And then for the bottom number, we put all the factors of our leading coefficient. In this case, it's 3, so I got plus or minus. And the only things that multiply to make 3 are 1 and 3. Well, now we got to go through and divide this. 1 divided by 1, 2 divided by 1. So this right here, 1 divided by 1, 2 divided by 1, 3 divided by 1, 4 divided by 1, 6 divided by 1, 12 divided by 1. Nice thing about that is we just get the same answers we already have, right? So we are going to get plus or minus 1, 2, 3, 4, 6, and 12. And now we go through and do the ones divided by 3. Well, 1 divided by 3, that's something new. I'm going to put that there, 1/3. 2 divided by 3, that's something new. That's going to be 2/3. But everything else actually doesn't do anything. 3 divided by 3 is 1. We already have it. 4 divided by 3, ooh, that one's actually new. I lied. 4 over 3, that's a good one. Okay, 6 over 3, well, that's 2. We already got it. And 12 over 3, that's 4. We already got it. So we're just going to close our parentheses, and these would be all our possible zeros. All right, on to this last page here. This one says, which of the following are the zeros of this function? So I'm going to start by just trying to see if I can factor this by grouping. So we'll put our parentheses and see if we can do some grouping here to solve this. Actually, I'm not going to do that yet. Look at this. Everything has a 2 in common. Let's factor a 2 out. So factor a 2 out here. We got 2x cubed plus 3x squared minus 2x minus 6. Be mindful of that. That would be terrible to work through that whole problem and be stuck because you didn't factor out a GCF. Now I can go ahead and do factoring by grouping. So I'm going to group these two together and group these two together. So I still got this 2 in front. We'll bring it back at the end. But if I look at the first grouping, what would factor out of x cubed plus 3x squared? Well, that's going to be an x squared. So I end up with x squared factored out, and I got x plus 3. And the second one, I can factor out negative 2, and I got x plus 3. And it looks like that's going to do it for us. As long as these two things match, we're going to get a good answer. So we got x plus 3 and x squared minus 2. Again, don't forget we still had this 2 in front, so I'm going to put it back in front right here. Well, we know then that one of our zeros is negative 3, and the other one we're going to add 2 and then take the square root. So x squared equals 2, square root both sides, so x equals plus or minus the square root of 2. So those look like our 3 zeros we're going to end up with, and that looks like answer choice D is going to be the one we want then. For 33, it says, which of the following is a zero of that function? So we're going to go ahead and use some synthetic division here. We're going to break out that synthetic division. So let's start with that negative 2. If negative 2 is a 0, we're going to list 4, 9, negative 3, negative 10. Bring down our 4. 4 times negative 2 is negative 8. Add that together when we get positive 1. 1 times negative 2 is negative 2. Add that together, we get negative 5. And negative 5 times negative 2 is positive 10. We get 0. Oh, look, that was quick. Remember, you're looking to get 0 here. If you get 0, that's the answer. But if you don't get 0, then you have to keep going. So, for example, if you looked at the next one, let's just do negative 1 to see what that looks like. Bring down our 4. 4 times negative 1 is negative 4. Add that up, we get 5. 5 times negative 1 is negative 5. Add that up, we get negative 8. Negative 8 times negative 1 is positive 8. Add that up, we get negative 2. This number is not 0, so we know that negative 1 doesn't work. So if you did get one like that, you would know to keep going. That's what we're looking for, is that 0 at the end. Our 34 says, given that 1/3 is a 0, find all the zeros. So we need to rewrite this as its linear factor. The way we would write 1/3 as a linear factor is we got x equals 1/3. So I'm going to multiply both sides by 3. That cancels out here. And now I got 3x equals 1. And I'll subtract 1 from both sides. So 3x minus 1 equals 0. So this is the linear factor they gave us. I can't really do synthetic division with that. So the only way I can figure out what 3x minus 1 does when we take it out is to use long division. So I'm going to long divide that all out. So I've got 3x minus 1 being divided into 3x cubed plus 2x squared minus 19x plus 6. Let's work through that. So 3x, to get to 3x cubed, we need an x squared. X squared times that is 3x cubed. I'm going to change my sign as I go. So minus 3x cubed. X squared times negative 1 is negative x squared. So plus x squared. That way we don't have to worry about the subtraction step. So 2x squared plus x squared is 3x squared. Bring down the negative 19x. 3x, to get 3x squared, is going to be plus x. X times 3x is 3x squared. Change to minus. X times negative 1 is negative 1x plus. Change it to plus. And we got negative 18x. Bring down that 6. 3x times negative 18x is going to be negative 6x. Negative 6, negative 6, sorry, not x. Negative 6. Negative 6 times 3x is negative 18x. Change the sign as positive 18x. And negative 6 times negative 1 is positive 6. Change the sign, it's negative 6. Cancel, cancel. We got a remainder of 0. We did it right. So now I know that this factors into 3x minus 1 and x squared plus x minus 6. And do I have two numbers that multiply to make negative 6 and add up to make positive 1? I sure do. X plus 3 and x minus 2. The question said find the zeros, so we need to make sure we list it as the zeros. X equals 1/3, x equals negative 3, and x equals positive 2 as our zeros. 35 asks us to identify the end behavior of the function. Well, the end behavior is based off the exponent and the power at the beginning, the power and the sign. Ultimately, I'm going to have to FOIL this all together, but you don't really have to. All we care about is if I multiply x and x and x and x, I'm going to end up with positive x to the 4th. So I know it's positive, meaning it should go up on the right side, and I know that it's even, so the left side should copy it, so it should go up on the left side. So I need two infinities. So as x goes to negative infinity, remember this part never changes and this part never changes. X goes to negative infinity, x goes to positive infinity. So all we're really focused on is that part where it says f of x. So in this first one, it says f of x goes to negative infinity, positive infinity. That's a good one. And positive infinity. That means on the left side, it's going to positive infinity. And on the other ones, negative infinity, positive infinity, that one's good because it's going up. Negative infinity, positive infinity, that one's good because it's going up. So it looks like the answer we got to choose is D because it's going up on the left and up on the right. And for 36, which of the following functions could represent the graph given? Now, you could way overthink this. If you wanted to get some crazy stuff and try factoring all those, you could. But let's pay attention to the important things. I can see that there's a 0 at negative, 1. 1 may be at negative 1 point something, and 1, there's 2 zeros. That's a lot of zeros. That's a lot of zeros there that are decimal, so you don't really want to think about zeros. But I do see it's going up on the right side and up on the left side. They're both going up, so it's definitely even because they're both going up. And it's definitely positive because it's going up on the right side. So looking at our answers, what can I eliminate? This has a negative, so it can't be this one. And this one is odd, so it can't be that one. So we can eliminate those right away. And at that point, honestly, the only thing you really need to look at is the y-intercept right here. If you plug 0, it's got to cross the y-axis at that y-intercept. This one crosses at negative 5, meaning C has to be the answer because it crosses at negative 5 and not negative 6. So C would be the one you'd want to pick there. And for 37, it says, below is a graph, figure out which of the following statements is true. And they gave us a few statements. First, it says, G of x is a 6th degree function with a positive leading coefficient. First off, it is not positive. Look, it's going down on the right. That is not positive, let alone the fact that it said 6, which is even, and it's going up on the left. This is not that. It's an odd function because they're going different directions, and it's a negative function because it's going down on the right. So it can't be A because that's positive and even. Same thing with D. D is even and positive. It can't be that. So look at our last two answers. X is a factor of G, and the multiplicity of X. Oh, I missed. The multiplicity of X equals 0 is odd. Well, let's talk about this. Multiplicity. Remember, we said if multiplicities are even, they bounce, and if they're odd, they cross. Well, look here. At 0, it looks like it gets to 0 and it bounces. So that should mean this is an even multiplicity, not odd. So C doesn't work, meaning B has to be the one that works, and it is. Think about this. This is x plus 1 is the factor here. X plus 0, or x, is the factor there. This is x minus 2 is the factor here, and here is x minus 3. So x is a factor because 0 is one of the zeros there. I know this is a longer video. I hope this helps. Let me know.